Okay, so now we're going to talk about how to shift a sine curve. So shifting sine curves. Okay, they're very similar to what we did with conic sections. Everything works pretty much the same. So you've got y equals a sine. There's two ways that this equation can be written, so I'm going to show you both. It could be b times x minus h plus k, which for that, everything works the same way that our conic sections did. H and k then are going to be your starting point. And then from there, we use b to find our period. So our period still equals 2 pi over the absolute value of b. And then a is still our amplitude. And so everything else that we do is exactly like we did a few minutes ago with the graphing basic sine functions. Here we're just shifting them off of the origin or off of the y-axis. Okay. If it's written in this form, things get really simple because you can just take the absolute value or the opposite value of the h. But why does that happen? Well, when you take the opposite value of the h, you're actually doing x minus h equals 0. So you end up adding h to both sides, and then you get the true value of h, okay? So true h value, rather than a disguised h value up here. So if you have a positive number, let's say that you have a positive 2, okay? X equals positive 2. Then what we had done with conic sections is we moved everything right 2. Okay, what we'll do today, we'll have something like x equals pi over 2, because everything we're doing with trig and period uses radian value, so we'll do pi over 2. So we would move our graph right pi over 2. Okay, if we had an x that was a negative pi over 2, then we would move everything left pi over 2. Okay, so it's easy to see if you had, for example, y equaled 3 sine of 2 times x minus pi plus 1, then your absolute value of a would be 3, or your amplitude would be 3. Your period would be 2 pi over 2, which would be pi. And then to find your horizontal shift, you would take this, really simple then. If you solve that for 0, x equal, or x, let me erase that, sorry. X would equal positive pi, because we just move it over to the right and then we would change the sign. So x would equal positive pi. So that would mean that for your horizontal shift, you'd be going to the right pi. Okay. Then for our vertical shift, just as we did this k over here, moved it vertically with our conic sections. We're talking parabolas, circles, let's see what else. Parabola, circles, then all of our polynomials, sorry, all of those moved up and down. And then the number on the inside in here moved it left and right. So vertically there, so this means we're going to be moving up 1. Okay, so if I plot that, instead of starting at 0, 0, I'm going to take this and I got to first figure out where my period is. So my period is over here at pi. Okay, I'm going to want to do 2 of them, so I'm just going to kind of eyeball how far over I'm going. So I'd say about right here is going to be 2 pi. The best thing to do is use graph paper, because if you're eyeballing, you're not completely perfect. None of us are anyway. Then here would be pi over 2, and then here's halfway between pi and 2 pi. Remember, we need to cut it into fourths, so we need to at least see these tick marks. Okay, so here's 1, 2, 3. 1, 2, 3, so that I can see our amplitude. And so now I think I'm ready to go. Instead of starting at the origin then, I'm going to shift it right pi up 1. So I'm not actually using this point. I'm coming all the way over here, all the way over to pi, and going up 1, and this is the point I'm going to be using. And now instead of oscillating over my x-axis when I make my curve, when I do this, okay, this balance line is not going to be the x-axis now. now that balance line is going to be right here. It's actually your K value that you're going to oscillate up and down over. Okay, so this is where I'll start. I'll start at pi. I'll go one full unit out, or one full period out. So right here, I've got 1, 2, 3, 4 tick marks to my pi. So 4 tick marks for my period. 4 ticks per period is just happened to be what I drew. So then I'm going to count 1, 2, 3, 4 tick marks, and that's where my period's going to end. So now I've got my start and my end. And now I go halfway in between, since it's a sine function, and I put that other so-called 0 there. Okay, it's again where we're crossing that balance line. So now I can deal with my maxes and mins, and so halfway between the first and the second 0, since this is a positive sine graph, I'm going to go up 3. Wait a minute, I can't be on the 3 then, because I'm at 1 that I'm oscillating over. So I have to count up 3 from 1, which puts me at a maximum y of 4. Okay, so you have to add that amplitude, or just start here and count 1, 2, 3, and place your dot. And then do the same thing over here, halfway between your middle and your end. Halfway, go down 3. 1, 2, 3. So there's my minimum. And that's how I would then graph one period. Can't see on my shadow. There we go. So there's one period of that shifted function. Okay, I'm running out of a little bit of room, but you would just do that again back here. Okay, so you would go over to 3 pi now with your tick marks, and you would do the same thing. Okay, the other thing that you could do if you needed to was you could come to the left side if you wanted, and just make sure you make me a note that this is where you actually are starting, right here. Okay, and then what you could do is you could use 0, or you could use pi all the way to 0 and do this to show me 2 periods if you're running out of space. Okay, and then you just copy it. So halfway between my first and my second, I'd be up here at 4. Halfway between my second and my third, I'd be down here at, that would be at -2. And make my little graph. Sorry, I've got a shadow on my screen. There we go. And there's 2 full periods. Although I know that I actually started, my go point is right here. Okay, so we moved this point off the origin, right pi, up 1 to our new starting point. We're not using that one anymore. And that's how we graph a shifted sine curve. Cosine would work exactly the same. But I do want to show you in case the b is set up a little differently. Okay, so if you've got y equals, the b could be inside the parentheses, a sine times bx minus c plus k. Okay, I changed the value on that from an h to a c because I can no longer just call it my horizontal shift. Okay, I truly have to take what's inside here. There's a little trick to it, and I'll show you what it is right here. You've got your bx minus c, and you have to set that equal to 0 and solve. So you end up adding c, or actually that's the opposite of c. You get bx equals c, and now how do you solve for x? You divide. So divide by that capital B, or whatever was being multiplied by x. So x then equals c over b. Okay? You can just plug right into there if you want to. Since this was minus, you would have to definitely change the sign. This was minus right here. You'd have to change the sign when you move it over. Okay, so just make sure you do that. So let's take an example of that. If you have one of my worksheets, it's actually problem number 1. You know what? I'll do problem number 2 because we did number 1 in class. So problem number 2 says y equals, oh, no, you know what? I will do problem number 4 because problem number 2 is a cosine equation. So y equals -2, this is number 4 on our worksheet from school, sine of 4x plus pi plus 5. Okay, So first we need to identify the amplitude and the period. That's a sign there. So our amplitude is the absolute value of A, so that's going to be a positive 2. But we do need to realize this 2 right here is negative. So when we make our graph, we've got our balance line. We're actually going to have to come down underneath it because when that's negative, it flips it over. So that's what our graph should look like. Our period is going to be 2 pi divided by 4 because it is this number that's in front of x. That is our b. So then we simplify that, and our period is pi over 2. Okay, horizontal shift then, we're going to take this, everything that's inside of here, and set that equal to 0 and solve. So we'd have 4x plus pi equals 0. Subtract your pi from each side, so we get 4x equals negative pi. Divide by 4, so x equals negative pi over 4. And since that is a negative, we're going to move left pi over 4. Okay. And then lastly, vertical shift, we're going to go up 5. That's from this k value right here. Okay. All right, so now let's actually plot that and graph it. Oh, we're going to go left, so I'm going to make sure I have some room over here. Oh my goodness, we're going to be up 5. Let me move that down a little bit. I hope I have enough space. So always be willing to readjust. So 1, 2, 3, 4, 5. I'm going to put these fairly close together. Okay, so my balance line is right here at y equals 5. That's what I'm oscillating up and down over. My period was pi over 2, so I'm just going to find a spot. Here's pi over 2. And I'll just do that again. So that would make this pi. That's 2 periods. So halfway in between, and then quarters. So from my y-axis over to pi over 2 is showing you 1 period length. Okay, so normally I would start with it being sine on the origin, but I can't start there. I have to take this, let's see, so this is pi over 2, so here's pi over 4, so I only need to go 1, 2 tick marks over to the left, negative pi over 4. So I need to take this, left pi over 4, up 5, and now I'm starting right here. And I would do the same thing. So 4 tick marks, here's where I would have started, 1, 2, 3, 4, is 1 period. So now that I have this placed, I just go 1, 2, 3, 4, and there's the end of my first period. So halfway between puts me on the y-axis. And now I need to deal with my amplitude. So halfway between the beginning and the end, I need to make a max or a min. So since this was negative, I'm going to start with a minimum. I'm going to come down first. So I'm going to come down 2 from that balance line. And then between my second and third zeros, I'm going to go up 2. So here is 1 period. And then I just copy that. So I count 4 more tick marks, so I need to come back over here and fill in this second period right here. So I've got pi over 2 up to pi. I need a halfway mark, and I need a halfway mark for those spots, my quarter marks. Okay, so now I have everything divided up, and I can go start at this end, 1, 2, 3, 4, and there's the end of my second period. Halfway between those, I have another 0. Halfway between the first and the second mark, or first and the second zeros, I have a minimum. Halfway between the second and the third zeros, I have a maximum. And I hope I'm hitting actually 2 here. I'm trying really hard to. And then I come down, come back up, and complete. So this is 2 full periods of our function. Okay. I'll work on some cosine videos for us, but I hope this gets you started. You learned about cosine in class today, so I hope this helps you out. All right, if you have any questions, make sure you guys let me know. Thank you.